Hi there. In this video, we're going to be taking a look at the metric system, the base units and the prefixes that allow us to define some measurement scale. Along our travels, we might have encountered several metric units that we deal with on kind of a regular basis. Two units that you might be familiar with are the centimeter and the kilogram. So what are these units? Well, centimeter is a way to describe length. Kilogram, on the other hand, is a way to describe mass. In order to give you some frame of reference, if you're more used to the English system of making measurements, there's about 2.5 centimeters in an inch. And there's about 2.2 pounds in a kilogram. So just like inches and pounds are used in the English system, centimeters and kilograms are used in the metric system. And of course, as we know, the metric system is the system of choice in the sciences. And so we need to be able to deal with these kinds of units. Well, centimeter and kilogram is actually that unit. There's two parts to that unit. There's what's called the base unit, and then there's the prefix. The base unit is basically telling us what kind of a measurement scale are we using, and then the prefix is telling us how big or how small is that particular scale that we're using. So in the case of centimeter, centimeter, the base unit of centimeter is the meter. The meter, this basic unit of length in the metric system, is about a yard, in the kind of English system. Just a little bit longer than a yard, or a little bit longer than 3 feet in the English system. So all lengths within the metric system are somehow based on the meter. But then there's also a prefix there, right? We said it's centimeter, right? So centi is the prefix of this particular centimeter unit, right? If we take a look at kilogram, we can kind of get to the same thing. We can find the base unit of the kilogram, which is the gram. In the metric system, the gram is that base unit of measuring mass. Grams are similar to pounds. We can say there's about 450 grams in a pound. Another sort of base unit within the English system, or unit of mass within the English system that we might be used to hearing, is the ounce. So a certain number of ounces, 16 of them, make up a pound. A certain number of grams make up a kilogram. So gram, this base unit, tells us that we're dealing with mass. Kilo is the prefix that tells us kind of how big or how small is the mass scale that we're dealing with in this particular measurement, And so these prefixes, such as centi and kilo, are pretty well defined for us, just like the units meter and gram are really well defined within the metric system. No matter where you go, a meter is a meter is a meter. A gram is a gram is a gram, no matter where you're at. So the prefixes there have very specific definitions. And so I've kind of drawn that out here on this side of the board. And so if we take a look at this, if we think about our base unit, so let's imagine we're talking about the meter. If our meter is the base unit, what these definitions of prefixes say is that 1 meter is equal to 100 of those centimeters. So 1 base unit is equal to 100 of the centi base units. So 1 meter is equal to 100 centimeters. So centi is the prefix there. The abbreviation of that prefix centi is a lowercase c. If we continue down here, there's some other units that you might be familiar with. There's some other prefixes you might have actually heard before. So 1 base unit is equal to 1,000 milli of that base unit. Okay, so if we stick with meters, okay, we can say that 1 meter is equal to 1,000 millimeters. Okay, the prefix milli is 1,000 of that base unit. Okay, the abbreviation for milli is a lowercase m. We can do the same thing here for 1 million and 1 billion units. So 1 base unit is equal to 1 million micro of that base unit. So 1 gram is equal to 1 million micrograms. Okay, micro is the prefix. The lowercase Greek letter mu, okay, is the abbreviation of that prefix. There's such a thing as a nanogram or a nanometer. How small are one of those? If you took a gram, okay, and you divided it into a billion equal pieces, each of those little pieces would be 1 nanogram. Okay, so there are 1 billion nanometers in 1 meter. All right, nano there is the prefix. The abbreviation of that prefix is a lowercase n. Right? So what we were describing here from centi on down is if you take that base unit and you divide it into some number of parts. So for the centimeter, you're taking a meter and you're dividing it into 100 equal parts. Each one of those 100 parts is a centimeter. Okay? You take something that weighs a gram and you cut it up into 1,000 equal pieces. Each of those pieces would have a mass of 1 milligram. Okay? Same thing with a micro, same thing with a nano. You're taking that base unit, cutting it up into 1 million equal pieces. Okay? Each of those pieces is a millionth of that original measurement. Right? Well, we can go the other way. So this way going down is, from centi going down, is taking that base unit and cutting it up into smaller parts. Right? So from above centi, if we're looking in that direction, what we're defining is, well, what if we had some number of base units, some whole number of base units? Is there some way that we could describe another measurement scale, right? And so the one that I mentioned earlier that we might already all be familiar with is, say, the kilogram or the kilometer. Okay? So what a kilometer is, right? So a kilometer says that 1,000 meters is equal to 1 kilometer. 1,000 grams is equal to 1 kilogram. Okay? So it's, if we had some number of those base units and we added them all together, we could make some new unit. Okay? So in this case, 1,000, say, grams is equal to 1 kilogram. Kilo is the prefix. The abbreviation for that prefix is a lowercase k. Okay? One that is not necessarily used all that often, to my knowledge at least, is if you have 100 of those base units. So let's say you had 100 meters. Okay? Let's say you traveled from point A to point B and that distance was 100 meters. Well, we could say that the distance was 100 meters. We could also say that it was 1 hectometer. Okay? 100 meters, if we add them all together, that length, we can call that 1 hectometer. So hecto is the prefix. The abbreviation there is the lowercase h. Right? Even larger than that, if we had 1,000,000 base units, we would call that a mega of something. So let's say we a length of time lasted 1,000,000 seconds. Okay? Second is a base unit in the metric system. So we could say that 1,000,000 seconds is the same thing. 1,000,000 seconds is the same thing as 1 megasecond. Okay? Mega is the prefix. Capital M is the abbreviation. Okay. Same thing with giga. Okay. Giga is a billion of those base units. So let's say you might have um, a memory drive that's 1 GB. Okay, that's not a very good memory drive actually, but let's say you have 1 GB. What that's basically saying is that there are 1 billion bytes, okay, within that 1 GB, right? You travel 1 billion meters, you've gone 1 gigameter. Okay, the prefix is giga, the abbreviation is a capital G. All right, and so this is our plan for our method, our definitions for how we can change these base units, okay, prefixes that we can add to these base units to better describe our measurement scale. Right? One thing we're asked to do a lot in chemistry is to convert from, say, one unit system into another unit system. We might be asked to say, well, how many meters are there in 5 kilometers? Okay, we might be asked to say, how many milligrams are there in 7.2 grams? Something like that. So we need to be able to convert from one measurement unit into some other measurement unit by keeping these prefixes and abbreviations in our mind. Okay, so let me erase some of this on the board, and then we'll try a couple example problems. Okay, I've erased the board a little bit here and put up an example problem. And so our problem is, how many milligrams are there in 7 grams? Okay. In order to answer this question, we need to know what's the relationship between grams and milligrams. Well, we can check out our table over here, and what we see is that there are 1,000 milli of that base unit equal to 1 base unit. So there's 1,000 milligrams in 1 gram. So the question is, how many milligrams are there in 7 grams? Well, we can probably do that math in our head. If there's 1,000 in 1, then there's going to be 7,000 in 7 grams. Okay, but how would we write that out mathematically? Because sometimes they're not so obvious, right? So we're going to use a technique called dimensional analysis that we're going to continue to use a lot in chemistry. And so if you haven't checked out my dimensional analysis video yet, and you're having some issues with what we're writing here, I highly recommend that you check that out as well. So the question that we would be asking, that we're asking here, is how many milligrams are there, okay, in 7 grams, right? And so this is our question. Our goal now is to convert grams into milligrams. And the way that we're going to do that by dimensional analysis is try to cancel out the unit that we're given, the units of grams, and go to the unit that we want, which is milligrams. To do that, we're going to multiply by what's called a conversion factor. A conversion factor is a fraction, okay, well, is an equality that's been turned into a fraction, right? So we know an equality that relates milligrams to grams. We know that there are 1,000 milligrams in 1 gram, okay? Well, great. If we know that equality, we can turn it into a fraction. And in fact, we can turn it into 2 fractions. We could say that there is 1 gram over 1,000 milligrams. We've taken that equality to say 1 gram is equal to 1,000 milligrams. We've turned it into a fraction, okay? We can just flip that fraction over and say that, okay, well, there's also 1,000 milligrams in 1 gram. We've taken that same equality and turned it into a different fraction, a different conversion factor, okay? The fraction that we're going to choose here depends on the unit that we're trying to cancel and the unit that we're trying to end up with. Okay? In this case, we're trying to cancel the unit grams, right? And so if we have a number, what we want to do is divide by some number with that same unit. Okay? If you take a unit and you divide it by that same unit, the units cancel. right? So we've got grams here in the numerator, right? We've just got 7 grams. So if we've got 7 grams on top, we want to make sure that we have some number with the unit grams on the bottom. So it looks like we're going to want to use this conversion factor. I'm going to say that 1 gram is equivalent to 1,000 milligrams. Okay? And so look what happens. I'll have 7 grams. I'll multiply that by 1,000 milligrams. Okay? That'll give me 7,000 milligrams times grams. And then I'll divide by 1 gram. Gram on the top and gram on the bottom are going to end up canceling. So if I do that math here, I get 7 grams times 1,000 milligrams divided by 1 gram. Grams on the top and grams on the bottom cancel, and so the only unit that I'm left with here is milligrams. So that thing we did in our head, this is the math that you did in your head, right? So how many milligrams are there in 7 grams? Well, there are 7,000 milligrams. All right, I've erased the board, and here's our next question. How many megagrams are in 7,200,000 grams? Okay, here's a real example of how these prefixes really help in the metric system. It's really kind of inconvenient to write really large numbers or really small numbers. In those cases, it's really much more useful to use a prefix that signifies either a really big measurement scale or a really small measurement scale. Okay? So could we put 7,200,000 grams into megagrams, right? So the question that we want to ask here is how many megagrams are there in 7,200,000 grams? Okay, whoops, grams, right? Well, in order to do that math, I'm going to need a conversion factor again. I'm going to need to multiply by some fraction that contains an equality that links together grams and megagrams. Okay? Well, I can go up here, and what I see is that there are 1 million grams in 1 megagram. Okay? 1 million grams in 1 megagram. So that's our relationship there, right? And so I can take that relationship and put it into 2 different fractions, one with the 1 million grams on the top in the numerator, and one fraction in which the 1 million grams is in the denominator. Well, which one do I want? I'm trying to cancel grams, right? Grams is here in this number, and so that means that I'm going to want to divide by some number that contains the unit grams, right? So the conversion factor that I'm going to choose is to say that 1 megagram is equivalent to 1 million grams, okay? And so now when I do this math, which is going to be 7,200,000 times 1 divided by 1 million. Okay, that's my math. Multiply and then divide. When I do that math, I'm going to end up with grams in the numerator and grams in the denominator. If you have the same unit in both the numerator and the denominator, those units are going to cancel. And so now the only unit that I'm going to be left with is megagram. And remember, that's the unit that I'm looking for, right? So you might be able to do this math in your head, right? We're going to take 7,200,000, multiply it by 1. That's still 7,200,000. And then we're going to divide it by 1 million. Okay? If you take 7,200,000, divide it by a million, what you're going to end up with is 7.2 megagrams. Okay? 7.2 megagrams is the same thing as 7,200,000 grams, right? All right, I've erased the board and I've put up our last problem here. It's going to be a little bit more complicated. So the question asks, how many Hg, how many hectograms? Okay, remember hectograms here. How many hectograms are there in 17,453,000 micrograms? Okay, so remember in our last 2 problems we went from a base unit to some unit that contains a prefix. In this problem, we're going from one prefixed unit, or from one prefixed unit to another prefixed unit. Okay? We can do that. It's just going to be a little bit more complicated, right? So let's write out what our question is. Our question says, how many hectograms are equal to 17,453,000 micrograms? Okay? And so in order to solve this problem, what we need is for some relationships, or one relationship or multiple relationships, that is going to allow us to relate micrograms to hectograms. Okay? Well, if we look at our table, what we see is that there's 100 base units, or say 100 grams in one hectogram. Okay? But we don't see any exact relationship, one-step relationship that allows us to go from micrograms to hectograms, or hectograms to micrograms. Okay? We have a relationship between hectograms and grams. We also have a relationship between micrograms and grams. Okay? So we have two different relationships. Each relates the base unit gram to one of these two prefixes. Okay? So we can come up with kind of a plan in order to solve this problem. The unit that we're given is micrograms, right? So we're given micrograms. We want to try to convert that to hectograms. But looking at our table, we're not able to do that directly. But what we can do first is take micrograms and convert it into grams. Okay? Once we've done that, now we can take grams and we can convert that into hectograms. Okay? So this is going to be our path, right? This is our plan for how to solve this problem. Each one of these arrows here represents one of those conversion factors that we used earlier, where we take one of these relationships, one of these equalities, and turn it into a fraction, right? So our first step is to go from micrograms to grams, right? We're in micrograms, we want to go to grams, right? So let's say we're going to multiply by some equality that gets us from micrograms and then to grams, okay? So what we know is that there are 1 million micrograms in 1 gram, right? So we're trying to cancel out the unit micrograms. And so what I'm going to do is I'm going to say that there is 1 million micrograms in 1 gram. Okay. Now, when we do this math, say the 17,453,000, multiply it by 1 and then divide by a million, we're also going to take micrograms and multiply it by grams and then divide by micrograms. So we're going to end up with micrograms on the top and the bottom. And so those two units cancel out, okay? And so now the only unit that we have here is the unit grams, right? Well, we're only halfway there. We've gone from micrograms to grams. Now we need to go from grams to hectograms. Well, from our table, we know what we need to do. We know that there are 100 grams in 1 hectogram, okay? So we can set up one more of these conversion factors. So we're going to multiply by some fraction in which we say that there are 100 grams equal to 1 hectogram. Okay? You notice what I did here. I chose to put this fraction in this order with the 1 hectogram on the top and the 100 grams on the bottom. The reason that I did that is so in the end I would have 1 gram on the top, or I would have the unit gram in the numerator and the unit gram in the denominator. Those two units will cancel out, and now the only unit that I have left is hectograms. Okay? So now all the units are taken care of. The only thing I need to do is do the math, right? And so what I'm going to do is take this 17,453,000, multiply it by 1, divide it by a million, and then multiply it by 1 and divide it by 100. Okay? Maybe you can do this math in your head, but let's try it on our calculator. All right, so I brought up our calculator here. Let's take our 17,453,000, multiply it by 1. Of course, we still get the same number. We can then divide it by 1 million That gives us 17.453. We can now multiply it by 1. Of course, we'll get the same number. And then we'll divide it by 100. And what we end up with is a fraction. Okay? So all of this math equals 0.17453 hectograms. All right? So how many hectograms are there in 17 million micrograms? There's this many hectograms, right? So the procedure here is always the same. We're always thinking about this table that includes the base units and the prefixes. And we're using this idea of what's called dimensional analysis to allow us to convert from one unit system to another unit system. All right? I hope this video was helpful. I'll see you next time.